Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is second point in section 6.3, and it's about annuities due. Well, uh, for examples about annuities due: rent payments. You pay the rent at the beginning of the month, not at the end. Ordinary annuities we pay at the end of the month, but it is not always the case. Insurance premiums are also examples of annuities due. So, annuities due we pay at the beginning of the period. We made the payments at the beginning of the period, not at the end. And this means that one period will have more interest. Okay, annuity due draws interest for one period more than the ordinary annuity, one period more, because you pay at the beginning. So if you will deposit $1,000, for example, so you will pay the first deposit immediately, today, now, and then when you pay now, this deposit will get an interest at the end of the period. But in the ordinary annuity, you don't pay now, you pay at the end of the month, for example. So it doesn't work, it doesn't get any interest because you did not put any money. So annuity due draws interest for one period more than the ordinary annuity. That's why the definition or the formula for the future value of an annuity due is exactly the same as the formula for ordinary annuity, but multiplied by 1 plus I, because it will be compounded one more period. So we multiply by 1 plus I. Same formula, but you multiply by 1 plus I. This will give you the future value of an annuity due. So for example, find the future value of an investment if $150 is deposited. So this is R at the beginning of each month. So this, when you see at the beginning, this is annuity due. When you see at the end, it is ordinary annuity. At the beginning of each month for 9 years. So each month, so how many times per year? 12. So in the number of periods will be 12 per year times 9 years. So 12 times 9 will be 108. There are 108 periods. And the interest rate is 7.2% compounded monthly. So the interest per period is 0.072. I take the dot 2 units to the left divided by 12 because 12 times per year, and this gives you 0.006. So S, the future value, would be R, which is 150, times 1 plus I, which is 1.006, to the power N, which is 108, minus 1 over I, which is 0.006. This is exactly the formula of our ordinary annuity, but then you multiply by 1 plus I, 1.006. That's it. And you use the calculator and find the answer, and the answer would be 2836.59. So $22,836. So this is the future value of this annuity due. Suppose 100 is deposited, so this is R at the beginning. So this is annuity due of each month, so 12 times a year for 3 years. So what is the total number of periods? What is N? 12 per year times 3 years, 36 periods. Okay. What is the interest rate per period? Well, R is 6%. Okay. Compounded monthly, so I divide by 12, and the answer would be 0.005. What formula is used to find the future value of annuity? This is annuity due, so S is R times 1 plus I to the power n minus 1 over I times 1 plus I. Find the future value. Well, S would be the deposit is $100. I is 1 uh, 0.005. So this is 1 plus I to the power n, which is 36, minus 1 over I times 1.005, which is 1 plus I. And you put this in the calculator and find the answer. The answer would be 395.3.28. So $3,953. We also can use the formula for the future value of an annuity due to determine the payment size, the deposits, the payment size required to reach an investment goal, like sinking funds in ordinary annuity. Suppose a company wants to have, so this is the number we need to, the amount we need to have. So this is S, the future value. After 2.5 years to modernize its production equipment, how much of each previous quarter's profits should be deposited? So quarters. At the beginning of the current quarter. At the beginning of the current quarter. So this is annuity due to reach the goal. So what is N? N is 4 per year times 2.5 years, and that's 10 periods. If the company's investment earns 6.8, so I is 0.068 divided by 4 because there are 4 times per year, and this will give you 0.017. So now I have the future value, which is 450,000 equals R, which is not known, times 1 plus I, so 1.0117 to the power n, which is 10, minus 1 over I, which is 0.0117 times 1.0117, annuity due. And how to find R? You can divide all of this by all of this. Okay. If you want, uh, let me do it like this. You can evaluate this using the calculator. So 1.017 to the power 10 minus 1 over 0.017 times 1.017, and the answer is 10.98. Okay, 10.98. If you want to write 4, okay, 3 decimals, R. So R would be 4. You can keep the decimals in the calculator and you can divide 450,000 by the answer. So you get the exact amount. So 40967.39 dollars. So this is the deposit in this case, 40,000. Find the future value of an annuity due to 2000 paid. So this is R at the beginning of each 6 months. So 2 times per year for 8 years. So N is 2 times 8, 16, and I is 0.06 times 2 times per year. So it's 0.03. And S would be R, which is 2000 times 1 plus I, so 1.03 to the power n minus 1 over I times 1 plus I. And if you put this in the calculator, you will get 415 to 3.18. So about $41,523. How much? Of course, you always can check your answer approximately. So if you pay $2,000 at twice a year for 8 years, so you paid 2,000 times 16. This is the amount you paid. Okay. So it is 32,000. So this should be, of course, more than 32,000 because compounded semi-annually, you will get an interest. How much must be deposited at the beginning? So he's asking about R at the beginning of each year in an account that pays 8% compounded annually. So I in this case is 0.08 because it's compounded annually. And N is 8, how many years? 5 years. At the end of 5 years, in an account that pays 8 compound, so that the account will contain 24,000. This is S. So the future value is given and we need to find R. 1 plus I to the power n minus 1 over I times 1 plus I. If you divide this by this, or if you multiply this times R and then divide as I did in the previous in another example before, so you will find that the answer is 3,787.92 dollars. Also, you can check that if you multiply this times 5, okay, it should be less than the 24 because of the compounded of the interest you get. Okay, 92 times 5, you get about 19,000. So it, it gives you an indication that your answer is acceptable. A company wants to have 800,000 for office renovations. So this is the future value. If it can deposit 40,000 at the beginning of each quarter, so this is R, the deposit, each quarter, so 4 times per year, into an account that earns 5.2 compounded quarterly. So I is 0.052 divided by 4 quarterly, and this will give you 0.013. Okay. How long before the company reaches its goal? So the number of periods here is missing. So S, the future value, equals R times 1 plus I to the power n minus 1 over I times 1 plus I, annuity due. Now, how to solve this for n? Well, what shall I do? Okay, I will multiply 40,000 times 1.013 divided by 0.013. So this will give you, this is a 3, 116,923.077 times 1.013n minus 1. All right. And now I'll divide 800,000 by this number. It's about 0.2566, so 7 equals 1.013 to the power n minus 1. I divided both sides by this number. Okay. So now I take 1 to the other side. And now I apply ln to both sides. And when I apply ln, I can take n here using the properties of ln. And this n would be then n would be ln 1.2567 over ln 1.1013. And if you divide, this is 0, 1.013. The answer is 17.69. So this is 17.69 what periods. What is the period here? Quarter. How long before the company reaches its goal? It after 18 quarters. And 18 quarters, if you divide 18 by 4, you get 4.5 years. Okay, you can say 4.5 years, or you can just leave it 18 quarters. That's the answer. If 1,000 is deposited, so this is R, at the beginning, annuity due of each quarter again 4 times into an account that earns 8%. So I is 0.02 compounded quarterly. How long? Again, he is asking about N. Until the account contains 31. This is S. So 31,000 is equal to 1,000 times 1 plus I, which is 1.02 to the power n minus 1 over 0.02 times 1.02. And if you do the same process and solve for n, you will find that, please do it by yourself, you will find that n is 23.98. So after 24 quarters, or if you divide by 4, after 6 years, we will have 31,000 in the account. A family wants to have a 200,000 college fund for their children at the end of 20 years. So this is the future value. What contribution must be made at the end of each quarter? At the end of each quarter, this is an ordinary annuity. Each quarter, so 4 times per year, if their investment pays 7.6 compounded quarterly. So I here is 0.076 divided by 4, and this will give you 0.019. And the number of periods 4 times per year for 20 years, so this is 80 periods. And this is an ordinary annuity. So the formula S, which is 200,000, he is asking about the contribution, the deposit. So R is uh, unknown here. 1 plus I, so 1.019 to the power n, which is 80, minus 1 over 0.019. And we will not multiply here because this is an ordinary annuity. And R would be the division of 200,000 over this number. And if you use the calculator, the answer is $1,083.4. So this is the deposit. A small business owner contributes 3,000 at the end. So again, it's an ordinary annuity. This is R of each quarter, so 4 times per year, to a retirement account that earns 8% compounded quarterly. So I is 0.08 over 4, that's 0.02. How long will it be until the account is worth $150,000? So he is asking about M. And 150,000 is the future value, and 3,000 are the deposits, times 1 plus I to the power n minus 1 over 0.02, and it is an ordinary annuity because we said that it is at the end of each quarter. So let me divide 3,000 by 0.02, and then divide 150,000 over the answer, which is, by the way, 150,000. So the answer is 1. So 1 is equal to 1.02 to the power n minus 1, which means if you take the 1 to the other side, 2, if you apply ln, so n would be ln 2 over ln 1.02. And if you use the calculator, the answer is 35 quarters. So after 35 quarters, we will have $150,000 in the account. Suppose when the account reaches 150,000, the business owner increases the contribution to 5,000 at the end of each quarter. What will the total value of the account be after 15 more years? So what is the situation now? We have 150,000 in the account, and this amount of money will be in the account for 15 years. It is already in the account. So it will be compounded 15 years. What? 8%? 8%. Okay, compounded quarterly. So what would happen to this 150,000? How can I find out? The future value will be found using this formula, which we studied in 6.2. So the future value now, the principal in this case is the 150,000. R is 0.08 over M, which is 4, so 0.02. So this is 1 plus I actually. So it's 1.02 to the power MT, 15 years times 4, so to the power 60, because 4 times a year, compounded 4 times a year. So this is usually you multiply by 1.02 when you compound for one year, one period, okay? So this will give you 492,154.62. So this what would happen to the 150,000. What else? He will now contribute, he will put deposits of 5,000 at the end of each quarter for 15 years. So this is an ordinary annuity. So the future value, so let me say this is S1 and this is S2, okay? S2 for the future value of the ordinary annuity would be 5,000, okay, times 1 plus I, so 1.02, and in here is 60 minus 1 over 0.02. This is the future value of the annuity with deposit 5,000. All right. If you use the calculator, the answer is 5,702.57 dollars. So the total value in the account would be the sum of these two. And if you add these two numbers, you get 106,2412.32 dollars. So $1,062,412. That's the end of this section. I hope you can differentiate now between annuity due and ordinary annuities.